We're still working on quadratics in our review. So now we're going to look at our last two methods. We have completing the square and we have a quadratic formula. Now the nice thing about these methods is they work all the time. You can use them for any quadratic. The bad part is there's a little bit more work to them. So the idea behind completing the square is we're going to take something that doesn't necessarily factor and we're going to kind of make it factor. So if I take this equation I have right here, it is equal to 0, so that's kind of my first step. Also, if I have anything in front of the x squared, I want to get rid of it. So I don't have to do that here. So what I'm thinking is that if this quadratic doesn't factor, I'm going to make it factor. So what I'm going to do is I'm going to put the 9 over here where it becomes a positive 9. And then I'm going to choose the number that I want to go here. So I'm going to choose a number that will make it factor. But if I add something to one side of the equation, I know I have to add it to the other. So this is the step known as completing the square. I'm going to take this middle term. I want to half the number and then square it. So half of 4 is 2, and 2 squared is 4. So that's what we're calling completing the square, and that's the number I have to add to both sides. So the reason I chose this number is now this is going to factor. But not just into anything. If I notice, it'll factor into x plus 2, x plus 2, and I can write that as x plus 2 squared. So this is what we call a perfect square trinomial. And the reason this one's nice is even though I don't have a 0 over here, I can still make this work because I can take the square root of both sides. So I'm going to square root this side, square root this side. Don't forget your plus and minus on the right. So now the square root and the square cancel, and I'm left with just x plus 2 equals plus or minus the square root of 13. So it's kind of a combination of factoring and square root method, but you just have to pick the number that you want. So you take the number that you don't want and put it on the other side. Now to get x by itself, I need to move the 2 over. So I get x equals negative 2 plus or minus the square root of 13. So notice I didn't put it after the plus or minus. I keep the constants separate. Square root of 13 doesn't simplify. So I have an answer of negative 2 minus the square root of 13. That's one answer. Negative 2 plus the square root of 13 is my other answer. All right, so let's try one more. If we take b, it's already solved where it's all on one side and it's equal to 0, but I have that 3 there. That's a problem when we're completing the square. So I'm going to divide by 3 to get rid of it, but if I divide by 3 there, I have to divide all the way across. So I get x squared minus 12x minus 4, and then 0 divided by 3 is still 0. All right, so now I've got something that won't factor. So I'm going to make it factor. I'm going to pick my number that goes there, and it's not negative 4, so I'm going to move that over where it becomes a positive 4. So here's where we pick our number. So I want to take half of negative 12, right? So that's my middle term right here. That's what I'm looking at. I want to take half of it and then square. That'll be negative 6 squared, which will be 36. So now the left side should factor. Now if I factor this, it will factor into x minus 6, which is x minus 6 squared. And you may notice there's a bit of a pattern here. The number that ends up here is always that half number you get up here. So you'll kind of see a pattern with that. All right, and then on the other side I have a 40. All right, so now I have something squared equal to a number, so I can take the square root of both sides. I'm going to get x minus 6 equals plus or minus the square root of 40. I'm going to move that 6 over where it becomes a positive 6 plus or minus the square root of 40. So notice that 6 stays in the front. Now 40 will break down. If I break 40 down, I can go 2 times 20. That's 2 times 10, which is 2 times 5. So I can take a 2 out. Let me do that over here. So I get 6 plus or minus 2, and then the 2 times 5 stays in, so that's 10. So notice I put the 2 right in front of the square root because it came out of the square root. So my two answers will be 6 minus 2 square roots of 10 and 6 plus 2 square roots of 10. Okay, and those will be my two solutions. Now the last method we have is quadratic formula. So this one is your fallback method. It works all the time. So for quadratic formula, it helps if you have the formula memorized. We have negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have to figure out the a, b, and c. So what we do is we look at our coefficients. So I'm assuming a 1 on that x squared. So here's a 1, here's a negative 14, here's a 74. So that's going to be my a, my b, and my c. So that will be minus a negative 14 plus or minus the square root of negative 14 all squared minus 4 times 1 times 74 all over 2 times 1. So let's clean that up a little bit. The opposite of negative 14 is positive 14. And when you square a negative, it still becomes positive, so that's 196 minus, and if you multiply those together, you'll get 296 all over 2. So I want to caution you really quickly here. Most common mistake is people see the 14 and the 2 and they want to cancel. You can't cancel those, they are terms. So when you get to here, don't reduce. Okay, you actually can't do that. So what I want to do is keep cleaning up my square root, and I get 14 plus or minus the square root of negative 100 over 2. Now 100 is a perfect square, but since it's negative, I'm going to take out the negative as an I. So I get 14 plus 10i over 2. So when you're thinking about reducing, what you need is a number here, and here, and here. So every single term has a 2. So I'm going to factor a 2 out of the top. And once it's factored out, then I can cancel it. And so I have two answers. I have 7 minus 5i and 7 plus 5i. So something sort of interesting about complex answers is you'll notice these are conjugates. If you get a complex answer, its conjugate must also be an answer. Okay, so you can't get just one complex root. You have to get two at the same time. All right, so let's try B. Now this one is not set equal to 0, so it's really important that you do this first. I'm going to move these over to the other side, and when I change sides, I change signs. So that becomes a plus 12x and a plus 5. So I have to do that before I know what my A, B, and C are. Okay, so now I'm ready to do my quadratic formula. I recommend writing it down. I have negative b plus or minus the square root of b squared minus 4ac all over 2a. So b is 12, so this will be a minus 12 plus or minus the square root of 12 squared minus 4 times 3 times 5 all over 2 times 3. All right, so we're going to do some cleaning up. That'll be negative 12 plus or minus the square root of 144 minus, let's see, that's going to be a 60 if I multiply those together, all over 6. So remember here, you're going to be really tempted to reduce that 6 and 12, but you can't. So don't reduce. All right, you can't do that because you have this other term over here, this one, and it doesn't have a 2 in it yet. It may. All right, so we're going to keep going. We get negative 12 plus or minus the square root of 84 all over 6. Now I need to break down 84 and look for pairs. Since it's not a perfect square, it might simplify. I'm going to do this up at the top of the page. So that's 2 times 42, which is 2 times 21, which is 3 times 7. So I've got a pair of 2's I can take out. So I'm going to bring this up here. This becomes negative 12 plus or minus 2 square roots of 3 times 7 would be 21, all over 6. So now I'm ready to reduce. I need numbers in all 3 spots. So all of those are divisible by 2. So I am going to factor out a 2. That's going to leave me negative 6 plus or minus the square root of 21, all over 6. 2 goes into 2 once, 2 goes into 6 3 times, and I get negative 6 plus or minus the square root of 21 over 3. Now that is fully reduced, so I need to write out my 2 answers. I have negative 6 plus the square root of 21 over 3, and I have negative 6 minus the square root of 21 over 3. And those will be my 2 solutions.